So today we're going to summarize kind of what we learned about vectors yesterday. So first of all, what is a vector? A vector is a quantity with magnitude and direction. So a picture of a vector, and we started working on these yesterday, it just is an arrow with a start and an end. And yesterday we also started working on component form, and we looked at component form in its vertical form, where we had the x movement on top of the y movement. So again, if we were to look at a vector, let's say we had -3, 4. That means our vector starts somewhere. It goes backwards 3 and up 4. And we would connect those with our vector. So the x movement and the y movement. The magnitude of a vector, that's the length of the vector. So let's see, we have a vector here. And let's say this is vector W. And vector W, let's say it goes over 4 and up 3. So our component form of this vector would be 4, 3. And then the magnitude, the length, and a lot of times you'll see it with the absolute value sign, meaning magnitude. Well, yesterday we talked about what theorem you could do. Well, we could say 3 squared plus 4 squared equals W squared. And this is a 3, 4, 5. So our magnitude of that one is 5. And then the last one, the direction. The direction represents the angle between the positive x-axis and the vector. So, if we were to have, let's say our vector is going this way, so let's say our vector was -2, -6. The angle of our vector is between the positive x-axis, so that is our angle of the vector. Now a couple other vocab words that we're going to go through. Parallelism. Parallelism just means they're going the same direction. So you could have a vector up 3 over 3 up 2. That would be parallel to one that is going over 6 and up 4. Because you could think of that direction, rise over run, 2/3. This one would be 4/6. They have the same slope, so they're parallel. A position vector, it starts from the origin. So if you were to graph this, maybe that's vector W, and we say W equals 3, 2. But we could have a vector X over here, or Y. We could say Y is also 3, 2, but W would be the position vector. Unit vectors are any vector that is 1 unit long. And we use i's and j's. So I equals x, j equals y. So if you had a vector 3, 2, And unit vectors, 3i plus 2j, because it's like saying we go over 3 and up 2. So this is I, 1 unit long, j, j. Equal and negative vectors. Equal means the same magnitude and direction. Negative vectors are opposite direction, but the same magnitude. So kind of like going that way and that way. Those would be negative. So one thing we're going to take a look at here is let's see if we can find a vector here. So right beneath this, we're going to add an example here. And let's say we had, so example 1. Let's say, whoops, sorry guys. Let's say P is -1, 2. So you'll notice this is a coordinate. And Q is 3, 1. Find PQ, and I'll put a little line, and find QP. So P to Q, how do we get from P to Q? -1 to 3. So that vector, we would go over 4 and 2 to 1 and down 1. But how do we get from Q to P? 3 to -1. We're going down 4, 1 to 2, and up 1. So we have those vectors there. So let's see if we can draw some of these vectors here. So the next thing, we have a 2D vector. So P is 3, 2. So if we start somewhere, we go over 3, down 2. So here's vector P. As a unit vector, it would be 3i minus 2j. And the magnitude of P. So let's see, maybe 3 squared plus -2 squared. So 9 plus 4 is 13. So it's the square root of 13. So 1, 4. So we go over 1, up 4, and there's Q. So we would have 3i plus 4j. If we do the Pythagorean theorem on that, 16, 17, so the magnitude of Q is the square root of 17. R, backwards 2, down 5. So there's vector R. So -2i minus 5j. So let's see, 25 and 4, so the square root of 29. So now when we add and subtract these, we have Q minus P. So Q minus P, 1, 4, minus P, 3, -2. The way we do this is we subtract the x values and we subtract the y. So 1 minus 3, -2. 4 minus -2, minus a negative is plus. So we have 6. So now we have P, Q, and R. So 3, -2, minus 1, 4, plus R, -2, -5. So I might just look at the x part. So the x part equals 3 minus 1 plus -2. The y part, -2 minus 4 plus -5. So our vector, 3 minus 1 is -2, so we have -4. -2 minus 4, -6 minus 5 is -11. So we have -4, -11. Now 3 times q, we haven't done a multiplying, but when we multiply, all we do is multiply both of them. So this would be 3, 12. And then p minus 2r, so p, 3, -2, twice our R value. So that would be -4, -10. Let's see, so 3 minus -4, so 7. -2 minus -10 is 8. So on the back side, you only have one of these, and it's just showing a picture of a 3D graph, because vectors are in 3D too. They're not always in two-dimensional. And they have the exact same properties, except we have an x, y, z. So our x-axis, so if we were to put a coordinate here, we'd have, let's say we were to graph 1, 2, 3. So we go over 1, out to where this y, where those meet, and then we go up 3. So there would be our coordinate 1, 2, 3. Now again, these 3D ones, let's see, they have the exact same properties. So we're going to do a couple things with 3D vectors. So let's say you have this coordinate where A is 0, 2, 0, and B is 3, 0, 2. So if we were to find vector AB, 0 to 3, so we go up 3, 2 to 0, down 2, 0 to 2, up 2. And if we were to find the magnitude of AB, so we'd have 3 squared plus -2 squared plus 2 squared. So we got 9 plus 4 plus 4, so 13, 17. So AB would be, the magnitude would be the square root of 17.